Hello, this is Vivian Chan. Today in this video, I'm going to explain the 2018 HSC Mathematics Extension 1 question number 13. Question A. It asks you to use mathematical induction to prove this statement for integral n greater or equal to 1. Mathematical induction is a mathematical tool used for proving some statements, whether or not they are true or false. Statement means something which can be either true or not true. For mathematical induction, first of all, it has to make sure that the statement is true in the case n equal to 1. And then after that, we have to assume that this statement is true for some positive integer k. And then we have to check when k is true if k plus 1 is also true. Mathematical induction is like this. First of all, we have to check for the first case whether or not the statement is true for n equal to 1. Then we have to check if the previous one is true, then the next one is going to be true as well. So now n equal to 1 for this statement, when n equal to 1, the left-hand side should stop at 2 times minus 3 to the power 1 minus 1 is to the power 0. So the first term is the left-hand side when n equals to 1. It equals to 2. For right-hand side, simple. You just substitute n equal to 1. It is 4 over 2 is 2. Left-hand side equal to right-hand side. Therefore, it is true for n equals to 1. And then we assume that it is true for n equal to k. All the way sum up to 2 times minus 3 to the power k minus 1. It should be equals to this. Okay, assume this statement is true. And then how about for the next case? N equal to k, assume true. Next case should be k plus 1. Therefore, left-hand side should be all the way up to k. And then k plus 1, 2 times minus 3 to the power k plus 1 minus 1. Okay, by our assumption, the blue part here should be equal to this. And then we have to make sure that two things add up to be this one. But now the n equals to k plus 1. Let's take a look at this term very closely. You have 1 over 2. But here in this k plus 1 term, there is no 1 over 2. We have to make this 1 over 2 out. We can multiply the numerator and the denominator by 2 at the same time. Okay, now we both have 1 over 2, therefore we can factorize them out. And the first term here was left is the numerator 1 minus 3 to the power k. The second part is 2 times 2 be equals to 4. And then minus 3 to the power k plus 1 minus 1 means k. And then now let's go back to our bracket. 1 minus this one plus 4 of this one minus 1 plus 4. They sum up to be plus 3. So plus 3 times minus 3 to the power k. Now let's go back to our expected right-hand side answer. It should be 1 minus 3 to the power k plus 1. So instead of plus here, you should have minus. How to change the plus into minus? Plus means minus 1 times minus 1. Therefore, this plus, we can change it to 2 minus. So we have 1 minus 3 times minus 3 to the power k. So we have minus 3 to the power k plus 1. We have done here. What we have done is, if n equal to k is true, then the next one must also be true. That is mathematical induction. Question B of 13. The question provides you the graph of y equal to x over x squared plus 1 for all real values of x. The question also tells you that this function has an inverse. For the range x greater than or equal to 1. That means starting from here all the way, ask you to state the domain and the range for the inverse function of function x. Domain means what can goes into this inverse function. So started from 1 onward, what can goes into the inverse function? Let's look at the y, right? For x equal to 1, the value of y equal to 1 over 2. For x greater than 1, the value of y decrease. Therefore, the domain for the inverse function of x should be from 0 all the way up to 1 over 2. But the problem is why 0 is excluded. Let's take a look at the function of x itself. The function of x can be rewritten into this form by divided numerator and the denominator by x at the same time. So x divided by x goes to 1, x squared divided by x goes to x, 1 divided by x goes to 1 over x. Now, let's think about what happens to the function of x when the value of x goes very large. 1 over x would goes to 0. And this x is still very large. We will have 1 over a very large number. Therefore, the whole function value would goes to 0. But this 0 only appears when x tends to infinity. But infinity is not a number. Therefore, fx does not actually goes to 0. It just means when x gets larger and larger, the function value would approach 0. It doesn't stay at 0. Therefore, the domain of the inverse function of x does not stay at 0 as well. Question number 2 asks you to sketch the graph of y equals to inverse of function x. The question itself provides you the graph of y equal to function of x. So for inverse function, you just copy the graph of y equals to function x and then interchange the x and y axis, just like what I have just done here. And then change the y-axis, you just treat it as the x-axis, the domain, and then the x-axis will become the range, the y-axis. And then as you can see here, it is x equal to 1 over 2 and then y equal to 1, right? So from 0, when x is approaching 0, because x doesn't equals to 0, the value of y goes to very large, infinity. So the graph should be when x is approaching 0, the y value is large. And then all the way goes down until when x equals to 1 over 2. And here we should also indicate that the 1 over 2 and 1 should be included in the graph. Question 2 asks you to find the inverse function of fx. And here the question tells you that fx is actually this one. If we let y equals to fx equal to this one, which means you have to make x the subject of the function. By doing so, I multiply the denominator on both sides, so you get y times x squared plus y, and then this x on the right-hand side, I minus x on both sides, so that the right-hand side becomes 0, and the left-hand side, you have the minus x. Here, if you want to make x the subject, this is a conjugate equation in x. Here we go. So conjugate equation, it should be minus b. The b is minus 1, so minus 1, plus minus b squared minus 4ac. b squared is minus 1, minus 4a, a is y. C is also y. Take square root divided by 2a, a is y. Here minus 1 become 1, plus minus 1 squared become 1, minus 4 times y, it is minus 4y squared. Take the square root divided by 2y. Since x, the question said that we consider only x greater than equal to 1. 1 minus the square root thing is not going to be greater than or equal to 1. Therefore, we just forget the minus sign. X should be equal to 1 plus the square root of 1 minus 4y squared, and then the sum divided by 2y. Therefore, this is the inverse function let's just change because the question asks you to find the inverse function of x, the notation thing, you just change the y into x, dummy variable. So it can be x, it can be anything. Question C, it is about projectile motion. The question tells you that an object is projected from the origin with initial velocity v at an angle theta to the horizontal. The equation of motion xt means the horizontal displacement with respect to time. Yt means the vertical displacement with respect to time. Question number 1 asks you to show that the object is projected at an angle and the horizontal range should be v squared over g sine 2 theta. So horizontal range is talking about from the origin until the object reached the ground again. Therefore, the y displacement must be 0. So the y displacement was 0 at the very beginning, and then it will become 0 when the object returns to the ground. So here yt, the y displacement in terms of time, we want it to be 0, the y displacement equals to 0. First of all, let's factorize the t. Is t times this factor equals to 0. Two factors multiplied to be 0, it is either t equal to 0 or the second factor equal to 0. Then from this equation, we can find that t equals to 2v sine theta over g. The question is asking for horizontal range. So at t equals to the time that we have just found, what should be the horizontal displacement? It should be v times the t we found, and then times cosine theta. V times v is v squared over g, 2 sine theta cosine theta is sine 2 theta. So we have done. Question 2, it changes the angle of projection from theta to pi of 2 over theta. The question asks you, is the horizontal range going to be just the same? So now the theta changes to pi over 2 minus theta. Let's rewrite everything properly. Now 2 times pi of 2 minus theta, we multiply this 2 into the bracket. Pi of 2 times 2 become pi minus 2 theta. So it's now sine pi minus 2 theta. Sine 2 theta should be always equals to sine the supplementary angle of 2 theta, which is pi minus 2 theta. Two supplementary angles, they are always have the same sine ratio. This is the property of sine. Therefore, we have done here. Question 3, it is about what we have just done in the previous sections. If an angle is projected at an angle alpha, it would reach the ground at D. If the angle is projected at the complementary angle of alpha, which is pi over 2 minus alpha, and the question named it by beta, according to question 2, the object is going to land at the same horizontal distance as alpha. If the highest point from the ground, we name it by h alpha and h beta, the question asks you to show that the average of these two heights depends only on v and g. What we have done in the previous sections, when the object's at the ground, it is either at the very beginning when t equals to 0, or the object returns back to the ground at t equals to 2v sine theta over g. At t equals to 2v sine theta over g, the object has already traveled the whole horizontal distance d. But when the object is at the highest point h alpha, it is only halfway before it reaches back to the ground, which means t at the highest point is only half the values of this one. But this time, the angle of projection instead of theta, it should be alpha. So h alpha, the highest point, should be equals to, according to this function, t equals to v sine alpha over g. So it should be v times the t times sine angle of projection alpha minus g over 2 times t squared. As we can see here, we have this other square as a common factor. Therefore, we just take it out. What's being left for the first term is v squared over g minus g over 2 times v squared over g squared. So g and over g squared, we cancel one out. It will become v squared over 2g. Here, the subtraction of two fractions, we just get the same denominator but multiply 2 to the numerator and the denominator, and we have 2v squared minus v squared. Therefore, the difference is v squared. And h other equals to this one. Similarly, for h beta, it would have the same form as h other. Instead of other, the projection angle, it changes now to beta. And the average of the two heights, it should be sum of this 2 divided by 2. Let's take out the common factor of v squared over 2g, and we would have sine squared plus sine squared beta left. Beta is defined by the complementary angle of other. Sine complementary angle of other should be equals to cosine other. Therefore, sine squared other plus sine squared pi over 2 minus other should be equals to sine squared other plus cosine squared other. It is equals to 1. And now, the average of the two heights should be equals to v squared over 4g, which depends only on v and g, and it is done.